Hey, welcome back. Today we're going to be talking through how to do momentum explosion style problems, specifically for AP Physics C mechanics students, although this also could apply to students in a good regular physics, high school physics, or honors physics class as well. Alright, so let's go ahead and get to it. First of all, both of the problems I'm going to show are originally from the College Board. The first one I've modified the numbers, the second one I'll talk you through that one as well. You'll see how this works. Alright, so this first problem says an object with a mass m is moving with the speed v0 to the right on a horizontal frictionless surface. When it explodes in two pieces, subsequently, one piece of mass 1/3 m moves with the speed given to the left. So note you've got a before and an after. There's a little explosion here. We want to solve for the final speed of the second piece in terms of the initial speed. So let's think of this as a conservation of momentum problem. I would call this a 1 to 2 scenario. This is a situation here where you have a separation going on. Specifically, this is an explosion. So let's just come up with our equation. Remember, our basic equation is P is equal to m times v, and this 1 to 2 scenario thing that I write up here, it's just also to help you to think about like how many terms, mathematical terms, we're going to create with this equation that we need to write. So all of these are just base m. So lowercase m is what we're dealing with, and we could call this v0 is equal to, remember, momentum is basically conserved in almost every case that we can consider. The one exception is with like a accelerating frame of reference. We're not going to worry about that for now though. And so we have two pieces here. So note that this first piece has 1/3 m, and it's moving with the speed of v0 divided by 2. That's its value here, but it's moving to the left. We need to take that into account. So we're going to bring the negative sign out in front. That term needs to be negative. Plus, this is going to be 2/3 m, and we'll just call it v2. We actually don't know what this is. That's what we're going to be looking for. And so let's think about how to simplify this problem and so on. So first things first, what is something we could do to simplify the entire problem? Well, hopefully you notice that m is in every term, and so we can just divide it out. And notice we do want to get this v2 by itself, so I can go ahead and subtract this term right here and just bring it over to the left side. So we can say v0 plus, we have 1/3 times v0 over 2, and that is going to be equal to 2/3 v2, which is our unknown. Okay, well let's simplify this further. This is going to be v0 plus 1/6 v0 is equal to 2/3 v2. Well, how do we get a common denominator here? Well, what we need is a denominator of 6. So we can do that as long as we have 6 over 6. That's equivalent to 1. And so that'll bring us to 7/6. v0 is equal to 2/3 v2, and we want to get v2 by itself. So to get v2 by itself, let's multiply by the reciprocal. If we do that over here, you end up with 21/12 v0 is equal to v2. And that's going to be our answer, what these things are equivalent to. In other words, what v2 is in terms of v0. So I changed the numbers so it doesn't work out as cleanly as what their original problem had, but that's how you would go about doing this problem. Alright, let me show you a second problem here. And that's going to be right here. So it says a launch projectile splits in midair into two halves of equal mass. Equal mass is important here. Let's remember to focus on that. If the projectile had not split, it would have landed at point X. Here is point X. I've marked it with the black X right there on both of the diagrams. A distance R, so that's blue, to the right of the launch point. So R is in blue, and you can see where we're talking about, what our launch point is. And then on the left it says the halves hit the ground at the same time. So let's think about what that means. What does that mean in terms of this scenario? Well, if they hit at the same time, that means the v and the y for both of these projectiles that split apart. So there's an explosion in midair, and it splits into two parts, and both of those parts are going to land at the same time. That means the velocity and the y for both of them needs to be exactly the same for that to happen. And so that means we can kind of ignore what's going on in the y-axis. Okay, further the problem says if one piece lands at point y, a distance of 2r to the right of the launch point, where does the other piece land? So this, you can think of it as a conservation of momentum problem, because those principles apply here, but it's also a center of mass problem. I mean, effectively, you could say the center of mass is what lands at x. So if the center of mass lands here, and there are no external forces aside from gravity, so no external forces. Okay, so if there are no external forces in the x whatsoever, it's only an internal force, then the center of mass stays the same. That means the center of mass is going to be at x in both cases. And so what that means is if half of the mass is at y, then where would the other half of the mass be if the center of mass is going to end up being at x? Well, then you need to have the other half of the mass at this explosion. It's going to actually bounce back right here, and I'm going to try to draw this neatly, but basically it's going to bounce back and it's going to hit the ground, and I'm trying to draw this at the same elevation here. Not turning out terribly well with that. Maybe I should bring this down a little bit, but hopefully you see the idea here that the other part of the exploded projectile needs to land at the launch position for this to be a true statement, because the center of mass is going to be the same in both cases because no external force in the x-axis. So it's good to be able to think in terms of conservation of momentum for explosion style problems, but it's also good to be able to think about center of mass concepts as well, and the College Board will certainly test whether or not you understand both of those types of problems. As we conclude, I do want to say I've gone over all of the concepts for a high school physics class and most of the concepts for an AP Physics C mechanics class. So if you have any questions or comments down below, please let me know. And I hope you all have a great day. Take care.